All right, we are live here on this edition of the MSP Success Magazine webinar series. Really cool webinar that we have here today, but just a few housekeeping items super quick before we get started. I'm Jeff Johnson. I'm going to be a host of today's webinar. I'm the president of MSP Success Magazine, and we've got here an AI expert. I'm going to let Bronze introduce himself in just a moment here. But he's going to be talking about how the third wave of AI is going to change how MSPs get clients, manage data, make money. And so we've got a packed house here of attendees that is on the webinar. Very cool with this, and why I know some of you registered not just for the information, but also we are going to be giving away five $500 gift cards here on behalf of Dell at the end of today's webinar. So you want to stick on the webinar. You must be live on the webinar to receive that gift card. And so stick around for that here later on it, but we've got a ton of information to get into. And so Bronze, I'm going to turn it right over to you to be able to take it over.
Yeah, perfect. Let me share my screen here. Hopefully you can see this.
Let me see. Right now I'm getting, I think I'm just getting a backdrop there.
All right. All right. Can you guys see my screen right now?
I'm seeing the power. There we go. Now you're good.
Hey, perfect. Yeah, I really appreciate the opportunity to speak with you today. My name is Bronze Larson. Formerly, I am a PhD applied mathematician with about 25, 30 years in the artificial intelligence space. Spent a large portion of my career developing very high-end technology for both the US government as well as for commercial entities. And since I've been at Dell, I spent a couple years as the AI strategy lead and then a couple years as the AI ecosystems lead. And most recently, the office of the CTO, where I work, is kind of transitioning to more of a research kind of focused area. So kind of exciting stuff coming out of Dell. Today, I want to talk a little bit about something not a lot of people, I think, are quite aware of, which is where is AI going? And thinking kind of a few years out. I mean, right now, there's a lot of buzz and excitement around generative AI and AI, traditional AI as well. But I kind of wanted to paint a picture of what's on the horizon and what the impact is for everyone. Before I get to that, I wanted to touch on just a quick snapshot of what AI at Dell is like right now before I sort of step into the future leaning content. So Dell, in the office of the CTO, we are a very forward-leaning wing of Dell. And so we look at where data management's going, cloud, edge, 5G, security augmentation, quantum, and AI is sort of a horizontal across all these. It not only is affected by advances in these other areas, it also affects them as well. We kind of parse our projects and our efforts and our products and offerings into three broad categories. Other companies use similar nomenclature, but we call it AI in, on, and for. There's a new one called with, which I'll just touch on verbally at the end here. AI in, pretty self-explanatory. It's where we put AI in our products. Customers don't necessarily know it's in there, but they usually benefit from a product that runs cleaner, faster, quieter, cooler. And so it's something that makes our products have better performance, provide better results, or just run longer. And so the customer ends up usually with a better product in the long run. AI on, this is where we actually have solutions which allow our customers to realize their AI dreams on our hardware. So you can think of accelerator enablement, data management tools, the ability to really help customers manage their data, and run their different training and inferencing applications on our hardware. But we're not just sellers of AI, we are consumers as well. And so we have a category called AI for, which is really AI for us. A lot of the areas like you can think of that we utilize AI is, an example, parts failure prediction. So our ability to use predictive analytics to estimate when many of our products which are out in the wild might fail and what type of failure they're going to see. That helps us stock our repair rooms, help us prepare for potential problems that might arise, and be able to return these products to the customers more quickly. So again, customers maybe don't know that this is running, but it helps make a better experience in the long run. We have a new category called AI with, and it's really where we actually work with you right next to your side to actually help you realize your dreams with you. We have at any given moment hundreds of different projects that are ongoing. I think this snapshot shows about a 550 plus projects in various stages of development, from proofs of concept to things that are getting ready for full product deployment. I think the latest snapshot actually had that closer to 900, and a lot of that increase was due to generative AI, because we had a whole new area of AI applications that we're able to kind of spin up and start to understand what the benefits of this new technology is. We work across business sectors: manufacturing, defense, retail, energy, healthcare, you name it. We have customers that we work with and across a whole bunch of different verticals here. And to kind of bookend the type of customers we work with, I have two examples here. This was actually an AI on application where we were working with a very sophisticated type of customer, one which actually knew AI intimately, and they really wanted to have a data center built up. The application they were looking to work on was improving their Olympic standings of their athletes. So they wanted an AI-enabled sports data analytics lab created, along with edge devices that were allowed to be out in the field near the athletes wherever they were training around the world to do data capture. So for instance, with the rowing or the crew teams, we actually helped them integrate drones that could fly next to the boats and actually capture their movements and help them turn that into kind of stick figures, which can be measured and turned into numbers, which hopefully were able to be utilized to improve the overall standings of their athletes in the Olympics. So again, this is a customer who's very sophisticated. We didn't do the AI, they did the AI. We helped enable the entire infrastructure to be able to help them realize their AI dream. At the other end, we had a customer who didn't know how to spell AI and didn't want to know how to spell AI, but they had a problem. They had these self-checkouts all around the world, and they were having fraud. In particular, they were having people take a cheap item like a pack of gum, and they would hold it in front of a more expensive item like a bottle of wine, and the barcode SKU would bring up a pack of gum for $1 and they can get a $40 bottle cheaper. So we actually helped integrate in cameras and an AI system which not only could read the barcodes but could recognize the object and correlate the barcode to the object to say, hey, there's something a little bit erroneous here, and it could flag the staff to say, I think there's something going on here. Again, this was deployed around the world. We actually, acquired the model, integrated it into the system, and deployed these worldwide. So working with customers that are very sophisticated, like the Olympics example, all the way down to people who didn't want to hire AI experts, didn't really want to deal with AI. They just had a problem and they came to us for an answer. So Dell works with really everyone and everything in between. But as I think about the future of AI, I kind of took a three-pronged attack to trying to understand what are going to be the drivers, because often there's a change in the algorithms. There's something going wrong with the performance, the intelligence, the brains of an AI system, and that warrants a shift in the algorithms. And with that shift, it could mean changes to the hardware, the accelerators, the things that are needed to enable it, and new tooling to actually allow that to happen. But sometimes it's the other way around. It can be a hardware innovation. And I'll use the example of kind of the GPU. Neural nets and the algorithms were kind of stuck because they needed this very unique compute to be done in massive scale, parallel scale. And it was too costly to develop custom silicon, and the current chips that were out there just weren't fast enough. The GPU and the advances that realized that you could turn that into a general purpose processor, which actually did the very thing that neural nets and AI needed, that advancement is what enabled the algorithms to shift and allowed those to kind of take off. Sometimes, though, it's something different. I call it the make it easy task. And, it's more of an intangible. Sometimes there's just a tool which is so easy to use. It may not be the best algorithm providing the best intelligence. It may not be the fastest, but it's just so darn easy to use that ends up just having a certain stickiness and ends up being kind of the foundation. I look at some of the tools maybe that the hyperscalers put out there as sort of falling into this category. They're not always the fastest. Their intelligence isn't always the best, but oh my goodness, have they made it easy to use. I mean, they did such a fantastic job. I even think about, Microsoft with working with OpenAI and the Copilot. I mean, they literally brought this complex technology to the masses, and they did a fantastic job at making it easy. Granted, you might be able to still develop your own smaller model or RAG model and wrap it in a Copilot wrapper around it that might do a little better, but maybe not. And to be honest, what they were able to achieve with Copilot is pretty darn amazing, and they made it really, really simple. But there is this change, and the answer that I would say is the driving force is going to be the algorithms. And so in order to motivate why the algorithms, there's a new paradigm shift out there coming, I kind of need to beat up current AI. And I'm going to describe it in these waves: the first wave, the second wave, and the third wave. And this third wave is what I'm talking about today. It's still sort of in the future in terms of widespread adoption, but it's actually been around for a while in terms of implementation. The second wave is what we're talking about mostly these days with statistical methodologies, deep learning, neural nets, deep fakes, all the stuff you see online. That's really where we are right now, these statistical methodologies. And there's actually an earlier version of AI that was really popularized back in the 1980s, which is based on rules. And it does a really good job doing probably the most ubiquitous and used AI system that's out there. But I really want to motivate why there is a third wave, which means I'm going to kind of beat up the first and second wave a little bit before I get to why. So just to kind of level set, I mean, AI, I think everybody knows, it's really just the automation of some process. A lot of times people think it's automation of a human process, but that's not always the case. And there really are four elements of AI that determine what a system needs to achieve: perception, learning, abstraction, and reasoning. And what I mean by that is a system should have sensors which can suck in data from the world. I mean, imagine a car with a camera on it doing autonomous driving. The sensor is perceiving the world around it. It's taking that data and learning from it. And with that learning, it's able to make decisions and provide intelligence. But it should not be confined to what it's previously seen. It should be able to abstract and see a new object, operate on that, and not sort of fall apart. And at the end of all that, it should be able to have some logic in there to provide actual actionable intelligence and reasoning that someone is able to do something with. Now, the first wave of AI was really good at this last one because it was based on handcrafted knowledge. We knew the rules, we knew how it was supposed to operate, and we were able to just say, well, based on those rules, take this action. You can think of stuff like maybe an ATM machine. It used to be that you would go into a bank, there'd be a human teller, you'd maybe check your balance, deposit a check, and take out a little cash. Well, those rules are well known. So being able to automate that process in a machine that you could push some buttons and achieve the same tasks is kind of what that first wave of AI was. The video game industry. I mean, we know the rules for the game of checkers. We know that you can move diagonal and hop over opponents, and you can only move forward unless you get kinged, in which case you can move backwards. Those rules are really well known. So being able to automate that and make a computer play checkers against you is something that the video game industry has really probably dominated in terms of AI. So you've been using AI for a long time, maybe without even knowing it. But the problem is sometimes you don't always know what the model is, what the rules are, what the recipe is. And that's where you say, well, okay, I don't know what's going on, but I'm able to observe what's happening. And so can I take some pictures, gather some data, and feed it into a machine and have it sort of figure out the rules? And that's really where we are today. It's this statistical learning where you have a sensor perceiving and gathering a lot of data, and you pass it into this machine learning, and it sort of starts to use some voting schemes to say, well, this is likely how this should operate. And so that's really good. But unfortunately, it's sort of lost out on the reasoning capability. And it also doesn't have any ability really at all to abstract. It's what it's seeing is what it can operate on. If you train it up to recognize dogs and cats and you show it a fish, it's not going to know what to do. But this is what's kind of got into a lot of the computer vision, the autonomous navigation, the words that, I mentioned before: machine learning, neural networks, deep learning, deep fakes. And again, fantastic, but it is missing some of those other elements. And that's really what's driving the third wave of AI, which is predominantly aimed at doing adaptive learning, being fully explainable, and also operating with extremely limited or no data at all. So there's a lot of already, you could probably imagine some pretty monumental impacts on the world with this next generation of AI. Now, with all of these, there's two operating modes. You can do analysis or synthesis. And analysis is what most people think of as traditional AI. You see a picture of a dog, feed it into the system, and it says, ah, that's a dog. It classifies it. It provides intelligence. Or an autonomous vehicle driving down the road, it's looking at an intersection and it spots a stop sign. It recognizes a stop sign and gives you the intelligence that that's a stop sign, and allows you to then make a decision. But any one of these models that can do that, if you know what a stop sign looks like in order to be able to classify it, well, that means you also can generate or synthesize a stop sign if asked. And so that's really what the other version is of synthesis, which is I want you to create and generate a picture of a dog for me. And because it was trained up to recognize a dog, it can now generate a dog. And so that's what people think of with Gen AI. It doesn't have to be images. It could be words and text. You ask it a question and it generates a result. But it doesn't, it can be go both ways. A way to kind of think about that, an example might be the video game Madden Football. There's a physics-based model in there for how footballs fly through the air. And you can use that model to analyze a football that you spot in the air, and you can find out a lot of information, intelligence about where it was thrown from, what angle it was thrown at, the velocity. Maybe there's some wind drag that's causing, and you can detect where it's going to land. That same exact model, you can invert the process. You can feed in an angle, a velocity, some wind drag, and you can generate what it would look like for that football to fly through the air. That's generative AI. So again, you've been using generative AI for a long time, probably without knowing it. So thing about where we are right now is, a lot of people say, well, why do we need anything new? Isn't AI the cat's meow? Isn't Gen AI the cat's meow? And it is fantastic, but there is a lot of hype out there, which is sort of kind of confusing the world. And so, this was actually a little exercise I did where I just grabbed 6 of the top. I went into Google, just give me 6 top articles on AI. And at the top of each article, there's a picture that sort of encapsulates what the article is about. And I just posted these here. So pasted them here. The first one was AI is a brain. So that's the first one. The second one is, well, it's actually more than a brain. It's really now kind of a machine that reads and digests new information and chooses what it's self-learning, and it's kind of going off on its own, and you don't even need to really guide it anymore. And the next one said, well, it's not just intelligence, it's now contemplative. It's really starting to kind of, have almost emotion, and it's very thought-provoking. And the next one said, we have to really probably consider it that it's a life. We've given just like God gave birth to Adam in the Sistine Chapel, this one was kind of using that analogy to say we've given birth to a new life form. AI is a life form. The next one said, as a matter of fact, it's so good that it's really blurred the lines between human and machine. You can't tell the difference anymore. And the last 6th one was, it's so good, we pretty much have to consider AI probably having a soul. At the other end of the spectrum, though, I actually like to kind of tap into certain experts out there. And one of the organizations that I've spent a lot of time working with is an organization called DARPA, the Defense Advanced Research Project Agency. It's the largest VC firm on the planet. They've pretty much probably invented everything in AI, or at least funded the invention since the 1960s. They think about 25 years in the future. They're way out ahead of anyone else on Earth. And one of the organizations there, the offices are called I2O, was one of the biggest kind of developers of AI. And a recent director was asked not that long ago, hey, what do you think of AI? And his comment, a little different than the previous chart, was, well, artificial intelligence is not that intelligent. As a matter of fact, neural nets, they're really just spreadsheets. And I love that second quote. I actually use it quite often when I talk to people who get too excited about AI, or they get too afraid of AI. It's going to take a lot of jobs, the rise of machines, or it's the next gold rush. And I kind of say, oh, really? You think that Microsoft Excel is the next gold rush, or Microsoft Excel is going to take over the world? And then people kind of pause, they look at me funny, and it allows us to have a little more of a grounded conversation. Even other experts out there, recognized experts like Jeffrey Hinton, who's known as kind of the godfather of deep learning, not in the government space, in the commercial space. And he was sort of asked what's next for AI. And his comment was, oh, my view is to throw it all away and start over. So you kind of have these different views here that, well, maybe there's a lot of hype, but maybe there are some challenges facing AI today that are a little more practical and might give rise to some new algorithms. And that's exactly what the case is. Even some of the prognosticators out there, like Gartner, they put out a lot of these different hype curves and they move things around. This was just one I grabbed on algorithms. And if you look at some of the things that are in there, deep learning, generative AI, or deep learning, natural language processing, machine learning, chatbots, computer vision, autonomous vehicles, semantic search, even generative AI, it sort of puts it at this kind of trough of disillusionment or falling into it. And so, there's even some of these kind of general purpose prognosticators saying, maybe there's a little bit of a slowdown coming that we need to be aware of. But then if you look at what's on the horizon, it's sort of this physics-informed AI that is kind of moving towards artificial general intelligence. And that's the third wave of AI that I wanted to talk about today. So there is motivation. And I want to dive into a little more details to give you concrete kind of examples of why people are thinking about a new form of AI and what that looks like and what it means. I'm going to skip over this guy. So again, why a third wave of AI? Well, if you work in AI, you're going to be familiar with many of these, but if not, these might be sort of new. One of the biggest I've already mentioned is the non-adaptability. I mean, that's a human characteristic. Humans don't need to have seen something to be able to operate on. It's something that we're pretty good at adapting to new scenarios, and AI is not. Right now, if you train up an AI system to recognize a dog and a cat, again, it's going to have problems with something that's not a dog or a cat. I'm going to kind of skip over this one because I have a slide. The next slide actually touches on it, but it's interesting enough that there's actually a lack of data. I should say lack of information, but it's actually something that's sort of starting to rear its head with these statistical methods, which need data. Need data. And we're sort of running out. These current algorithms, unfortunately, have errors. When you have statistics, the only way to not have errors is to unplug the system. That's kind of a famous joke. And so these errors are unfortunately sometimes hard to detect, hard to mitigate, hard to reduce. And that may cause a lot of customers and users out there to sort of be a little cautious about using it because one, they don't even know when it happens because these things are unexplainable. And that's one thing that kind of bothers me because I actually like to be able to understand every single bit that goes through the system and understand when it's going to fail, how it's going to fail, why it's going to fail, what the impacts are. So this is starting to kind of really bother some people for certain applications. It doesn't mean that you can't use a system with a high fail rate to do something that doesn't hurt anyone, like recommend a movie, a streaming movie. Hey, that's okay. So what if you get it wrong 1 out of every 10 times or twice out of every 10 times? So what? The person maybe didn't like the movie so much. But if you're talking about autonomous navigation, you're talking about disease detection, these high false alarm rates and these error rates, start to become a real problem. And those are actually, much of this is captured in, governance. It's actually getting more complicated to be able to understand how to navigate these. And, the EU just came out with their EU AI Act, which has pretty significant penalties for getting things wrong. And so it's difficult to navigate that. I mean, even at Dell, we launched some software and found out we didn't comply and we had to roll it back, even with all of our great, AI experts and legal experts and everyone tracking this. It's still, you can make mistakes. The compute is something that is having trouble keeping up. I mean, you see all the time these articles about the environmental impact of training for generative AI. You hear about companies building nuclear reactors to try to handle it. So compute sort of hitting a limit, and the kind of core element GPUs, they weren't designed for this. So they're sort of kind of maxing out in terms of what they're able to be designed to do. So that's why you're having to kind of fill these kind of farms of GPUs to be able to kind of do the training. And just in general, AI is hard. As a mathematician, I mean, we don't even know why a single neuron fires in these things. We can't model more than about a layer deep. And there really aren't a lot of AI experts out there that can actually handle what's going on. I'd say the most important, though, is with any technology and any research, you always want to make it better. And it is not general intelligence. Keep in mind, generative AI is really just a stylizer. It's not necessarily designed to get the answer right. It's designed to sound like an English language for things like ChatGPT, or if you're doing generative AI for images, it sort of captures the essence of what you trained up. If you had trained up on Monet or Van Gogh paintings, well, everything you produce is going to look like a Monet or Van Gogh painting. So it's really sort of just a stylizer, and that can fool people into thinking it's smart when it's really just, you know, kind of looking at the words that are out there on the internet and saying, I think this is the next best word in this sentence. It does a really good job of it, though. So something new is needed, and naturally that's where third wave AI comes in. Now, before I get to that, I did mention the data issue, just because I get a lot of questions on this, and I wanted to kind of preempt that. Current AI is sort of reaching its performance limits, and you know, this is a cartoon graph, but on the x-axis there, going to the right, is the amount of data. So to the right is more and more data. But the AI performance on the y-axis there is sort of plateauing. And the reason is not that we're out of data, we're producing more data than ever. It's that the content within that data, the information, is not increasing. I was actually at a meeting with the intelligence community, and they were bemoaning this problem that they collect all the data on Earth and they're not really getting many more performance. They joked with an example of like Facebook. Like 10 years ago, Facebook was dominated by soccer moms posting pictures of their kids. 10 years later, if Facebook is dominated by soccer moms posting pictures of their kids. So more data, but it's not really adding to the overall performance. And I'll give another concrete example here about kind of the approaches is, you know, I worked on a couple programs doing submarine detection, and one of the programs was, hey, let's have billions of cheap biodegradable sensors. Let's cover the ocean, and you know, again, big neural net data collection, data approach to it. The other was, let's build a single highly sensitive sensor, specifically designed, the hardware, the algorithms, and try to solve this problem. And I can tell you that the one that's still going strong is that one. You know, I was actually out at the San Diego Supercomputer Center recently, and they were kind of talking about this as well, saying, you know, as we move to hundreds of trillions of features and next generation of generative AI, and a chuckle broke out in the audience, and people, yeah, the speaker said, oh, I know, where's that information come from to make that work well? That's another topic. So, you know, it's kind of known that this is a problem. And so, you know, this is kind of a famous quote: more bad data doesn't increase AI performance, it's really better algorithms. So I'm trying to motivate why there is a need for something new. To give you some concrete examples to bring it to life, I actually ran a drone lab for drone swarms. And boy, did I have great demos and examples, and I could show all this wonderful capability of drones chasing people through the woods and accomplishing tasks. And statistically, they were massively impressive. I mean, false alarm rates of, you know, 10 to the negative seventh, 10 to the negative eighth, 1 in a billion times it failed. But unfortunately, there were so many sensors on board these things, and they were doing so many fast calculations that they would hit, if they're out flying for an hour, they would end up hitting that 1 in a billion, and it would turn into a catastrophic failure. So it was like, okay, I could show all these great examples, 10-minute videos of something cool. I could show false alarm rates, which were completely small, but it turned into a daily crash, which meant that it was, you know, not feasible technology. So, you know, this is a real example of something. And you've noticed, if you've been following the auto industry, General Motors just got out of the autonomous driving business. They couldn't meet the requirements. Apple pulled out. So, you know, it's really hard to get these into a practical system deployed. They're also easily confused, current AI. A lot of people don't realize that minor perturbations, like in this example here, there's a neural net, a system trained up to recognize car logos, did a great job, almost probably close to 100% accuracy. But then a few raindrops, the picture on the right landed on it, and all of a sudden it said, nope, that's a panda bear, and it completely fails. So, you know, that's pretty dangerous, you know, for a lot of applications out there, real applications. And I come back to this non-adaptability, you know, that it's like, yeah, the left picture there, you know, AI can maybe do an okay job recognizing that's a dog, that's a washing machine, but it can't abstract and say like, well, can that dog go in the washing machine, and then provide reasoning that says maybe that's a bad idea. So that's where kind of the next gen AI comes in. So how do you do it? Well, it's really based on rethinking how humans learn, not how the brain is organized. See, neural nets are based on the literal physical connections to the brain, but it's not focused on learning. And if you think about it, current neural nets need millions and millions of samples, or billions, to try to learn something. And we don't need that. I mean, people and animals don't need 1 million samples to learn something. I could teach a little kid, I could draw a letter K in pencil on a paper, tell them what it is, tell them it's associated with the phonetic sound of K. And that kid's going to know the letter K for the rest of his life, whether it's red, green, blue, fat, skinny, Times New Roman, Arial font, even if a cloud looks like the letter K, or if it's inverted or flipped up or down. One sample, that's all humans need. We don't need tons and tons of every single variation that's out there. And to be honest, if you then showed that kid a different letter, the letter P, they might say, well, I've never seen that before. But I bet it's part of that alphabet you just taught me about, and I bet it's associated with another phonetic sound. So learning for us is completely different from the way neural nets are based. So that's kind of the foundation of the shift in the way we're thinking about how to develop AI algorithms. And it's this creative part that's really exciting about it. I mean, if you think about it, we invented Pegasuses. Well, Pegasuses don't exist in the world, unicorns with wings, but we're able to come up with it. We didn't have to see it in order to invent it. We can invent stuff that doesn't exist. J.K. Rowling's invented Hogwarts, a school of magicians. She didn't have to attend a school of magicians in order to invent it. So again, human learning is so different. So I'm going to kind of pass this off a little bit and say, now, I wanted to give some examples to let you know that this isn't just magic or a new idea. These are actually deployed out there in the wild today. This is actually a system that was developed by DARPA and eventually transitioned to Abbott. And this thing is capable. I worked on I had the original patent on this, but this is capable. It's a biosensor that's capable of detecting and classifying bacteria, viruses, and toxin. But the key element here is it had to detect those that don't exist yet, newly emerging or bioengineered. And we didn't have data on everything that's out there. You can't collect data on stuff that doesn't exist. So we had to have an approach that didn't require any data. And we sort of need it to work forever because there's always new viruses and bacteria that are constantly evolving. So it had to kind of have forever models. It had to have no data, and it had to work on and be able to abstract to the things in the future. And those are the tenets of the third wave of AI. This actually won the 2009 Wall Street Journal Technology Innovation Award, and it is deployed around the world in embassies, subway systems, post offices, sucking in air samples and classifying the different bacteria, viruses, and toxins in the seeds. It was one of the first to, to detect SARS and detected and classified as a coronavirus. So it's also explainable. So when it detects a bacteria, it can't just say, well, it's new or it's not part of a previous set. It says, here's some of the characteristics. It's the genus, the family, the species, and sort of it kind of gives you some information about the characteristics, which is explainability, which is really needed in order to actually trust an AI system. There's another version that was developed for human, and it can imagine you had a doorknob or a gas station pump, and you were to swab it with a swab, you would pick up all the DNA from people that have touched it, because we're constantly sloughing off DNA from us, everything we touch. And this is actually capable with no training data, because again, you can't have everybody in the world or people that aren't born yet. This is able to unwind complex mixtures of DNA up to 4 people. And this works even if they have not yet been born. So again, the characteristic of kind of forever models, this is something that operates and it has explainability about what it actually detected, and this abstraction capability. So these are systems that are deployed, and there's a lot of others out there. So there is something that is grounded in reality that is coming. It's just not quite ubiquitous yet. It's not general purpose, and maybe it needs that make it easy task wrapped around it, but it is this algorithmic change which is coming. So I try to think about how do you sort of explain it, and this is a little hand waving here, but imagine you had a sample where I don't know, you have 3 dimensions which are kind of listed by these 3 different sides of this cube, and the height of these little bumps are sort of the individual characteristics of whatever the feature is. I mean, maybe if we're talking about bacteria, maybe it's the genus, and the other dimension is the species, or if it's a virus, it's the viral load, or how contagious it is. It's some characteristic. And the way that this works is you actually generate, using first principles physics models, all the different combinatorics. And you search spaces for things that hypothetically don't exist right now. And all of a sudden, you might get a match. And when you get a match, because you generated these and you knew what you generated and you knew the inputs, kind of like that football where I knew I threw it at this angle and this I actually have the explainability to say I got a hit and here's what I put into it to be able to sort of explain what I'm looking at, and it is something potentially new. So if you think about the future, what's needed to make this a reality? Well, third wave AI requires a massive amount of generative AI. The example here is if I want to detect that girl on the right, I could have a database of people and check them, or I could generate, using generative AI, every person who could ever exist. Now, practically speaking, and computationally, you can't do that. And that's why, luckily, these algorithms have a very computationally efficient way to search that space, to generate everyone who could ever exist, and then rapidly converge that down to find the person that you're actually looking at. And so if you think about it, what's needed to make this happen is there sort of needs to be a new type of third wave AI chip that can really do this in a computationally efficient manner. And whoever builds that, and it just needs to be sort of good enough. I use the GPU example that GPUs weren't designed for neural nets and second wave AI, but they were just good enough. So whoever kind of comes up with this, I mean, who can do this parallel generative AI, they're probably going to control the market for quite some time because these are sort of forever models. So it's sort of the end state of AI. Now, why do I think that's the necessary kind of thing that's holding back? Well, because this is what happened in the past. So I actually had a program with DARPA back in 2000 where we were looking at neural nets, which were, I mean, they would take you 6 months to train up a little tiny model. And we knew there was power there, neural nets and the wave of AI we're in right now. And generative AI, we were doing generative AI back then as well. And it was really, really computation intensive. And we didn't want to build specialty hardware that would be different for every application or different form factor. And so we kind of perused the world of what was out there. And we realized that neural nets need a massive amount of convolutions, which is just a mathematical operation, but it needs a lot of them. And we found that GPUs were these low size, weight, power, cost, little parallel computers that did one thing really, really well, convolution. And so we had there was no compiler, no way to do this in a general purpose manner. So we had the program to develop the first compiler. And we actually, were working at the time with ATI, which became AMD, and NVIDIA on sort of this first ability to do general purpose compute. So that's really what jump-started the second wave of AI. The algorithms existed, they were well understood, but we didn't have a way to make it available to everybody in an efficient manner. So we're kind of in the same position. We're gonna need, instead of parallel convolutions, massive amounts of convolutions, the third wave of AI needs massive amount of generative AI. Generate an image, generate a word, generate a response, generate a video, generate. And it needs to do it in massive parallelism. And so we need a chip to do that, just like the GPU. And maybe I'm hoping we can find one out there that's good enough and has a nice compiler that anybody can use to actually make this a reality. And again, whoever does this, they're probably going to control the market. And I tag on that word forever, because again, these are forever models. These are kind of the end state. So it's a really big step that needs to kind of occur to take these third wave AI out of these one-offs that are always developed for one application into something like today, where we have anybody can use Gen AI and anybody can use regular AI and anybody can develop. It's really easy to do. We're not there right now. So there's still work to be done. But you can imagine a world someday where all the different applications, where we have systems, AI systems that are in cars, they're in intersections, they're in buildings, they're in hospitals, and they're just everywhere and at the edge, processing data in real time. And so you can imagine sort of this parallel generative AI happening all over the world. And so again, big opportunity there. We already have a lot of these applications out there in the military. This AI Navy, that's an AI fully autonomous ship that's out there floating around looking for submarines. And there's a lot of other different AI capabilities that are out there in the military. So again, there is a definite proven technology that exists. It's just not quite there, for general consumption in an easy manner, but it's coming. So if I think about the impact, well, a lot of those challenges I mentioned, the third wave AI sort of has the promise of overcoming them. And just think about the impact of like the elimination of training data. I mean, a lot of companies struggle with data management, just even curating it. Well, there's no data, so that goes away. There's no retraining or drift that occurs right now if things kind of change, because it's generative AI third wave AI is always hypothesizing the new things that don't exist. So it's never drifting away from reality. Security and privacy issues are sort of minimized because often they're associated with data privacy, data security, and there's no more data that needs to be kind of stored. And so you think about the impact to edge, cloud, storage, security, less data will be needed to drive this newer AI innovation. Even the GPU market, I mean, it could be severely hit because these new algorithms don't necessarily need GPUs. They're not the right compute element for this next wave of AI. Even AI ethics becomes less applicable because, well, if you're not having lots of data, AI ethics often talks about using people's data, usage rights. I mean, you've seen some of the challenges some of the big companies are facing as they suck in information from the internet. Well, next gen AI doesn't use data, so all those usage rights and people's, privacy and security out there. So a lot of the AI issues to data explainability issues, everything that goes into these sort of goes away. But the biggest to me is that last bullet or the right hand chart I have there, which sort of says it's really where the universe of third wave AI works. It's everything. It's all the things that if you ever have proofs of concepts for second wave or first wave AI that you kind of try them out and you go, well, it didn't quite live up to the reality because of this limitation or that limitation. Those actually become now a reality. So if I try and think about what is third wave AI, I think about first wave AI was where in the 1980s, we kind of did a lot of robotic, it was the age of robotic process automation. And really third wave AI is about this abstraction, this creativity, always staying at the forefront of innovation. And I actually think, well, and this is my opinion, third wave AI, what it really enables, it's not the age of robotic process automation where you implement certain rules. It's really the age of innovation automation because it's always able to create stuff that the world's never seen before. And to bring that home is actually an example here where, I try to bring home like using generative AI or, imagine you were to train up on only 80s data. Well, if you ask generative AI to create stuff, it would sort of be stylized like the 80s. You might be able to say, I want 2 palm trees, a girl in glasses, a sunset. And you are creating that and you're driving that. But, the style, because again, Gen AI is a stylizer, it would be in the style of the 80s. What it would not be able to do is it would not be able to create this. If the 80s was dominated by perfectly manicured hair, it's not going to generate someone with dirty, unwashed hair. If it's bright colors and sharp clothing with sharp edges, it's not going to come up with earth tone, kind of grungier clothes. And if the music is bright and major chords and pop with fast beats, it's not going to come up with minor tone, kind of feedback, grungier styles. That's what the third wave AI sort of is able to do, jump out beyond training sets to create stuff that sort of the world has never seen before. So, in many ways, with second wave AI, you're still the artist because if you look at that upper right-hand picture, you still have to tell it to make a picture with X, Y, and Z, or give me something in a certain style. Third wave AI, though, is sort of where AI can kind of start to become the artist and create things that have never been seen before. So, I'll pause there, and I'm going to hand it over to Aaron. Hopefully you found this sort of intriguing and interesting, and at least it piqued your interest to that there is other stuff coming down the pipe, and you might want to start thinking about it. What the impact will be. Again, it really applies to everything you can do with AI today. It just augments it and gives it far more power. If there's ever things that you tried using AI and maybe you had to shelve it, you can kind of reinvestigate those with the third wave of AI. Again, I want to caution it's still going out into the future. We're thinking far ahead. It is not something that is in the masses right now. It's really kind of specialty organizations know how to develop this and are developing a lot of one-offs. But due to the challenges facing AI today and the interest in AI and where people are finding so many wonderful applications, innovation doesn't stop, and the new challenges that are being overcome with this are going to be fantastic. So thank you. I'm handing it over to Erin here, and she can talk a little bit about Dell's Expert Network program.
Hi, everyone. My name is Erin Sutter. I'm a program manager for the Dell Expert Network. This is an affiliate program for MSPs and IT consultants, giving you guys benefits back for recommending Dell products to your end users. So there's 5 main benefits to you guys joining this program. First, you'll get access to a business advisor. They're there to help with everything from order taking, quote building, really just being your single point of contact at Dell to ask any questions to. You'll also get access to 2 different time-saving tools, Tech Direct, which will allow you to self-log support tickets on behalf of your end users, as well as um, Live Optics, which is free vendor agnostic software, giving you visibility into your end users' performance data. We have the MemberNet portal available to you guys. This is where you'll go to access free MSP specific educational content. You can also earn up to $20,000 annually in Dell Expert Network rewards off of all orders placed by your end users, and then turn around and use that money towards future Dell purchases with us. And then last but not least, it's a great way to consolidate billing. You can actually include your IT service fee onto the Dell lease agreement. That way, the end user is only having to pay one vendor each month. A lot of times people ask me, am I a good fit for the program? If you are 100% focused on hardware reselling, you're seeing high margin come from that, you're happy within the partner program, then I would tell you to stay put where you are. Within the partner program, if you're somewhere in the middle, maybe you are doing harder reselling, you're also an MSP, you're not seeing great margin come from that, I would encourage you to reach out to me after this presentation is over. I'm happy to have a more in-depth conversation with you to see if this would make sense for your business. However, full transparency that you cannot be in the partner program as well as the Dell Expert Network. So you would be giving up your tax exemption status and that sort of thing in order to join our program. And then lastly, if you're 100% focused on managing your clients, you're not doing any sort of hardware reselling, then you're absolutely the right fit for this program. It's free to join, and really, you're just getting benefits back. Just wanted to show you guys a quick snippet of what our member portal will look like from the customer side. Awesome. Well, if you guys have any questions on how to join or anything like that, feel free to reach out to me. My email is erin_sutter@dell.com. You can also go to our landing page listed above, scan to connect, all of that. But thank you guys so much for joining, and I'll pass it back over to Jeff.
All right, I think we've got some questions for Bronze. Bronze, can you do me a favor and just enable my video? I think we accidentally passed all the host capabilities over to you there. Or the AI did it. I'm not sure which one. All right, there we go. All right. I do see a couple questions, and just as a reminder for everyone, we are going to be doing in just a moment here after questions. I've got the 5 winners drawn for the $500 gift cards. Those are Visa gift cards on behalf of Dell. So there were a few questions. Let me go back on here. I know a lot of people loved your presentation there, Bruns. So is AGI considered the third wave?
Not necessarily. It's to some degree, AGI really is where people think it's literally a human. It's indecipherable from a human, and we are still far away from that. Third wave AI is really the tenets of an automated system. And currently, there are some shortcomings with second wave AI. So third wave AI really moves to the point that almost any automated system that you want to work on, it raises the bar to have higher accuracy and explainability and all these other issues I talked about. It's still not a human. And there's a great example out there. There's a benchmark that has been created, and it's called, I think it's pronounced Gaia. You can look it up. But what it says is AI is probably pretty good at certain tasks that might be even very complicated, but not so good at sometimes simpler tasks. And for example, AI might be able to do a lot of heavy computation and create and invent, but it can't click that little box at the bottom of the web page that says, check this box to prove you're not a robot. So, there's kind of come with these benchmarks of these things that probably we're going to need to move more towards AGI. It's things that are more human that are really not captured yet. So, but it's on the way. It's on the way towards AGI. And again, there's no guarantee we're ever going to reach AGI. So I just want to kind of caution that as well. It's this term that was coined. It has sort of a meaning, but it's so far off. There's no guarantee that we're ever really going to achieve that, besides very narrow applications.
Harold was asking here, how can we preserve trust in AI when we eventually can't discern real from fabricated?
Yeah, so I mean that's a fantastic question, and there may have to be some caveats attached. That's going to be the governance side of things. It'll probably have to add some sort of caveats to some of this stuff to make sure that some rules, some regulations, some laws about creating it without people's knowledge. I do believe, though, I mean, I remember, and how many years ago we would get emails from people that we all believe to be true, and then there's a point when you kind of realize, I know there's not a prince in Nigeria that's going to offer me $1 million, and pretty soon that sort of dies off. I kind of think we're going to get to that point too, and I see it a lot with my kids where they're like, they see something on TV, and they just go like, it's probably AI. They just sort of, it's like there's this natural sort of evolution of, I don't believe things that I see, emails I get all the time. I'm more, kind of cautious. And I think it's just so new to us that we haven't quite adjusted. But I think that there's going to be, some of that happening, that when you see something that's a little fanciful, you kind of go, well, okay, I saw it on the internet. It may not be correct. And there'll have to be some validations added somehow. And we're not there yet. But great question.
Yeah, I think there is that big piece of the governance, which will be, it's all a matter there of how it's revealed. I know there's some things that are out there even right now for the AI calling. We had someone that's a legal expert that was at our event last week that Dell was at as well. And they were wanting to make sure in our terms that it said you could actually call by AI, because the government is trying to regulate that, of saying,
Right,
if you're using AI dialers or anything else, then you have to reveal it, at least to certain audiences.
Yeah, and I think I come back to the biggest issue is probably more of the error rates associated with real AI systems. I mean, in many ways, the models don't really have a resume. And so you don't know what it doesn't know until you ask the question. And we saw that with the Gemini fiasco, that until you asked it to show a picture of George Washington, you didn't know it couldn't do that. And there's a lot of other examples like that, because Gen AI is making an amalgam of a lot of statistics that are out there, you really don't know what each model can and can't do until you ask the question. And so you have to be able to live with calculate these false alarms and live within those means. And I use that example of recommending a movie. 10% false alarm right there, probably not a big deal. But doing a cancer diagnostics, it might be a little more of a challenge.
Steven's asking a question here. From your perspective, Bronze, how can we use AI to increase revenue and acquire new business?
So Gen AI we've seen a lot of customers and clients and folks out there utilizing it for that very application and seeing good returns. They're able to increase their throughput and surface new customers faster by maybe aggregating, because Gen AI does a good job summarizing. So they're able to get these quick summaries and be able to categorize different clients according to what they're interested in and triage them more quickly. So we are seeing that application of Gen AI, actually the fruits of that labor. Now, there's a caveat here that unfortunately there's some practical bottlenecks down the line. And when we talk with a lot of these folks, they'll say, I generated 50% more leads, customer leads, but we haven't yet optimized our downstream processes. So we're not able to quite turn those leads into ROI yet because there's bottlenecks down there. So again, I think that's going to be one of the best applications of Gen AI, being able to surface and aggregate and summarize and quickly kind of weed through all this data more quickly and efficiently. But again, there's going to be some practical issues downstream.
Well, I mean, when you look at something, just a very basic example on this, of being able to sift and sort through data is that if you've got a list of, and I know some people that are on here that are TMT clients and are looking at scrubbing through a list and finding who the decision makers are in 1,000 names on a list. If you hand that off to someone in your office, that might be 3 weeks worth of work, 4 weeks worth of work of going through, searching on the internet, making dials, everything else. You give that to an AI, you've got it back in 10 minutes, all
Absolutely.
sifted and sorted and called and verified, and the web checked and everything else to make sure that the names are spelled, the people are still alive, and everything else. And so there's a lot that really gets to that point of now you've got that ability to now with using those type of tools to be able to make it where you can just really focus on spending your dollars towards the right prospects.
Absolutely. No, it really is
Easy example.
it really is an enhancement tool that, you know, gives you time to maybe frees up maybe some of the mundane parts of your job to allow you to be more efficient at the real creative and the impactful areas of your job. And we're seeing that, absolutely seeing those efficiencies across the board, whether it's in retail or banking or healthcare. We're seeing that same story being kind of realized.
Well, I'm going to do this. We've got 4 minutes left, and so I want to make sure we get to the winners here before the top of the hour. And so I did poll these just before, and so running down the list, I believe everyone here that I've got is still on the webinar. First up, the first winner, the $500 gift card, is Justin Mills from TRG Networks. Congratulations, Justin. Next up is, I hope I'm saying this name right, Heber Rodriguez from RRG Network Solutions. Congratulations on that $500 gift card. All right, perfect. I got it, Heber. Next up, our third gift card goes to Richard Colwell, Technique Business Solutions. Fourth is to Cindy Cole of Networking Delaware. And then the fifth and final $500 gift card is Conrad Forrest with MTS Consulting Group. Congratulations to all 5 of you for winning the $500 gift cards. Our team here at MSP Success will be in contact with you to be able to get you those out in the mail. So with that, I think we're here at the end of the webinar. Thank you very much for everyone for participating, and we look forward to seeing you on the next MSP Success webinar series. Thanks all.